I'm happy to introduce Lindsay, who will be introducing Sigit, but I'm also happy to invite you that after this seminar we'll be having drinks and meals in the Chinese garden, and everyone is invited. There will be both alcoholic and non-alcoholic drinks and some chips and just basically. So please, Lindsay.
Thanks everyone for coming along. It's my pleasure to introduce Sigit today. Sigit's from Indonesia, as you probably know. He's worked for many years at C4, and through sort of various relationships we have with C4 Centre for International Forestry Research Organisation, is headquartered in Bogor. And I met Sigit on an island off the south coast of Sulawesi. We worked out how long ago, at least 5 years ago, Sigit?
Yeah, mostly. 2014.
14? Hello. I'm a little nervous about dates. Today is my birthday. So. Anyway, so yes, long association with Sigit. Sigit was there helping us to sample soils out of pristine mangroves right through to heavily degraded mangroves. And he decided to sign up for a PhD in Rio. And he's now at near the end of his PhD journey, and you're going to see the fruits of some of his and our labour today. So, without further ado, take it away, Sigit.
Thank you, Lindsay.
No worries.
Yeah, good afternoon, everyone. Thank you for coming in this seminar. So, today is I'm going to present my result, and also this is a teamwork results from a systematic review project, and this is also part of my first chapter of my thesis in here. Yeah. As Lisa said, I've been working measuring mangrove trees across the Southeast Asian countries, Vietnam and also Indonesia, starting in 2012. So this one is somebody took my picture in West Kalimantan in 2013. And today, I'm going to share with you, discuss with you about our very new findings and forthcoming publish. And it's about the response of the mangrove carbon stocks and soil greenhouse gas emission, GHG greenhouse gas emission, to the land use land cover change, the LULCC. And this is a systematic review study. So,
try on the keyboard here.
Yeah. So this is the big picture of the global carbon cycle in Earth. We have so in each cycle we have the budget. We have the numbers where the numbers are defined by 5. We call it the carbon pools. We have the arrow here. We call it a carbon sink that absorbed by the forest, the carbon that in the atmosphere absorbed by the forest and also the ocean. And we have also carbon emission coming from the land use change, particularly from the land use and cover change, from the deforestation, from the agriculture and things. And this is a carbon emission that coming from the fossil fuels, like your transport, your car, emitting the carbon to the atmosphere. And here, specifically, we want to discuss about the land sink and also the land use change, particularly the mangrove ecosystem in the world. And here is the pool and also the pathway of the carbon in the coastal wetlands. That's not only mangrove but also saltmarsh and seagrass. So we have the mangrove vegetation here, and the mangrove vegetation absorbing the atmospheric carbon via the photosynthesis, and they also respire the CO2 from respiration, autotrophic mechanism, but also they sequester the carbon into the soils via the sedimentation. We call it the autochthonous or in situ carbon production and also ex situ carbon production. So basically, why mangrove is so important in terms of the carbon storage, because they receive the carbon that coming from the ocean and also from the inland, and also the in situ production from the net primary productivity. But once you remove the mangroves, there will be emission. And also, not only emission, but you remove or you lose the ability of mangrove in terms of sequestering the carbon. So land use, when you back here, it's only 10% of the carbon emission in the world compared to the fossil fuel and industry. But there's a double effect, like you're losing the carbon from the land use conversion, but you're also losing the ability of the carbon sequestration via the forest. That's the double effect. And here is I show you the key papers of the mangrove and carbon. If you search in the literature database, there is several 5 key papers from the 92. So the first 3 papers highlighting the importance of the mangrove into carbon storage, and that's associated with the mangrove production and also the carbon burial via sedimentation. And in 2011, these guys are measuring the carbon stocks across the Indo-Pacific mangroves, and the first study that reporting the amount of the carbon stock is about 1,000 ton carbon per hectare at the time. And then by then, there is a shortage of in terms of the publication or papers that published by researchers. And in 2014, this guy from the AIMS quantify or doing the literature review on the carbon cycling and also carbon budget globally, but it's not very systematically, but there's still literature review. So why mangroves again? Mangroves are among the most carbon rich in the tropics, especially the carbon that stored in the mangroves are located in the soil. So about 80%, 90% of carbon stocks in the mangrove ecosystem are in the soils. And then why the soil mangrove is so high in terms of the storing carbon? Because of the high carbon burial coming from the sedimentation. And recently, new term to promote this ability in those ecosystems to sequester a huge amount of the carbon, researchers already introduced the term of the blue carbon, which consists of the mangroves, saltmarsh, and then seagrass. And then also, if we look at specific by countries that having a huge amount of the huge area of this ecosystem, like Indonesia, so there is a huge implication in terms of the national carbon emission reduction. The findings in 2015, basically. So here is the figures of the carbon stock in ton per hectare, and mangrove is champions. So actually, this is almost 1,000. It is the average of the tall mangroves in the tropics, like Indonesia, like Bangladesh, Sundarbans, and India, and also Amazon mangroves. So the amount of the carbon stock is about 1,000 something. And this one is tidal marsh, and this one is seagrass. So those trees is termed as a blue carbon ecosystem. If you find the literature or new conversation about the coastal carbon. So here is the landscape transition. So we already know what the landscape transition is, and for example, in the mineral forest, not in the coastal, we have the old growth of the forest and then deforested and then converted into the annual crop production like agriculture or oil palm or timber plantation, and then modified again because we have money, and then they put the money for the reforestation or restoration, and that's also happened in the mangroves. So here is my study site in West Papua. So this one is a mangrove area, and the black one is ocean, and this one is the green one is mineral forest, upland forest. So they clearing the mangroves for the timber production here. This is the image, the picture that we took in the field. And in some cases in Indonesia, also it's across the world in the tropics also, there is a conversion of the mangroves into aquaculture, into saltpond, and also recently, because mangroves are so awesome, like people talking about mangroves, so they put the money for restoration. So here is the mangrove plantation that conducted by restoration program or rehabilitation program across the world. So by looking at this picture, we know that the carbon stocks is storing the amount of the carbon in the vegetation and also in the soil. So if you see this one, so you may imagine what happened to the carbon stocks dynamic across the landscape transition. Basically, this is what we hypothesis in this our systematic review. And here is the big picture of the mangrove conversion drivers in Southeast Asia. So we have a lot of mangrove conversion into rice field happening in Myanmar, in Wardi Delta, and also mangrove conversion into oil palm in the western of part of Indonesia and Sulawesi and some part of the East Kalimantan, where belowground and also greenground work. There a lot of mangrove conversion into aquaculture in the last 2 decades, basically. So people talking about the carbon stock in the mangroves, and people talking about the land use, deforestation in the mangroves, and there is also estimation of the emission, the global estimation published in 2011. It is estimating global carbon emission from the conversion and degradation of vegetated coastal ecosystem. Basically, this is a blue carbon ecosystem, mangrove, seagrass, and submars, and they come up with the highest carbon emission coming from the mangroves because the carbon stock per area, the density is highest compared to the other two. So the global estimation are based on the global mangrove extent and also the rates of the deforestation and the rates of and the factor like conversion factor in terms of the carbon emission. Not necessarily differentiate between the land use and cover chains, which is maybe different. That's what we are doing here. So when last year we also see the publication estimating the carbon emission using the same methodology, but using the most recent deforestation rate data, using the global forest watch data. And here we go. Like, what is systematic review, and why systematic review? So basically, you here as a academia, you know exactly how review is, but systematic review is more specific, like research question driven. The review that based on the specific research question that we call it a systematic review, and sometimes people misunderstand between what's different between systematic review, literature review, and meta-analysis. So in meta-analysis, in systematic review, you may not necessarily using meta-analysis, because meta-analysis is the way or the method how to quantify the quantitative data between control and then the control and treatment side or studies. That's meta-analysis. So here we have the carbon stocks as an outcome. We have the undisturbed mangroves. We have the treatment mangroves, which is land use land cover change impacted mangroves. So I use the undisturbed as a control, and then the land use land cover impacted as a treatment. And I use this both systematic review and meta-analysis to analyze the data, basically. So here is the step of the systematic review. So maybe if you conduct the literature review for probably PhD thesis, you can start and stop the review at any time when you want, right? But the systematic review is very systematic, step by step, from the developing a question, research question, and then conduct the literature search, identify relevant article, critical appraisal, data extraction, and reporting. So these can be repeatable and also should be consistent. And it must not be like you just conducting data extraction without this one. It's not a systematic review. Yeah. So this is the milestone. So I've been here starting in 2016, 3.5 years ago, starting in January. So in February we got submit a proposal to the C4, the FID for funding on the evidence-based forestry research initiative, and then we got the fund to running the systematic review based on the idea that I mentioned previously. So we had the first workshop in April in 2016, and then we have a second workshop in August in the same years. So we published the protocol. So each systematic review should be has a protocol, meaning that in the future, somebody, if you want to do or conduct the same study with the same research question, it can be repeatable, and should be consistent based on your protocol. So we published in around September 2016 our protocol, and first literature search end of the year, and then the second literature search. Why we conduct the second literature search? Because we find very small number of the papers at the time, and then we wait for sometimes. And while the team, we have a team. It's not only me, so busy with other areas. So just abandon our work and then start again doing literature search again. And then we had a meeting workshop again in last year, basically. And then we have a very strong debate in terms of how can we define the criteria, because the papers that we collected at the time is very small in terms of the population, because we strict with the paid study between control and treatment sites. That's the reason. And then in the last year, we repeat again the literature search, we repeat again the data extraction and critical appraisal and other steps. And then the last 4 months, we write the report. So here is the objective or the main and the goal with these questions. Basically, you want to know how does industrial convergence affect carbon stocks and flux on the mangrove ecosystem at global scale. And then we have several following questions. Basically, the first one is want to know what data available, and the second one is what the change of the carbon stocks and fluxes between control and treatment studies or sites. And then we want to know also how does time since land use recovery change, because sometimes the mangroves are already converted 30 years ago, and they just measure the carbon stock, and then sometimes they measure very fresh conversion, like less than 5 years, and you want to see does the time affect our results. And the last, you want to see also how long the mangrove takes to recover following the land use and cover change, especially regeneration via restoration, rehabilitation, and plantation. So there's so many sites in the world or program that introducing mangrove restoration as part of the climate adaptation in the coastal area policy. So as I mentioned we conducted literature search 3 times. So we still use the same research, the same searching terms, and that's based on the what we call it PICO, population intervention and comparator and outcomes. The population is the mangroves, global mangrove ecosystems, and then the intervention is the effect of the land use before and after land use. And then comparator is between undisturbed and then disturbed control and treatment. And then the outcome is the carbon stocks and the flux. Specifically here, CO2 and methane flux coming from the soil before and after land use compression. And we conducted we applied this search term into the 3 main largest database online. We have Web of Science, Scopus, and CAB, CAP. And we end up with more than 5,000 papers based on this literature search term. So, what is the process? So we have 4 main process before data extraction. We identify basically this is from the literature database I saw earlier, and this is the screening. This is very time consuming and read the titles, reading the abstract of each papers, and then we read also the full text. And we strictly include this criteria to include or exclude the studies that we compile from the literature database. So in the end, based on this strict criteria and for the data analysis, we just came up with 37 papers, unfortunately. So what data did we record? So we record every detail of the data in the paper, provided in the paper, site information like citation, location, climate condition, land use description, time scene land use, where data are collected. For example, if the data provided in the table 1 in the paper, so we have to record table 1 in the paper, page 1, page something, page something. Yeah, that's very detailed in terms of the data collection. And then, what data? As I mentioned earlier in PICO, we in outcome of the study, we want to know the carbon stock data. That's coming from the 3 carbon stocks, root carbon stocks, and soil carbon stocks, and also the greenhouse gas fluxes from CO2 and methane. And also, in addition to support our findings, we anticipated further. We also collected the following data that also provided in the literature, such as forest structure, the tree density, the number of the trees per hectare in the sites, the basal area, the tree diameter, and also soil properties like soil depth, bulk density, and carbon content. And we extract the mean, the standard deviation, the minimum value and the maximum value, and also the number of the samples or replication. Here we go. So, long story. Here is the data availability. So this is not 37. So this is the data points that from 37 studies, and the distribution globally across the five main land use. We have deforestation or tree removal. We have the aquaculture. We have a pasture, some data in Mexico, pasture, and then rice field, some in Africa and Philippines. And this is other category. It's about salt pond and also the coconut plantation that replacing mangroves in the Philippines. And here is a regeneration. This is a restoration mangrove land use. And this is the still actually the same data, but the bottom map is based on the outcome. For example, this one is carbon stock data, and the chocolate one is greenhouse gas flux. You can see the gaps. There is no flux measurement across the African mangroves. That's what we want to show here. And this is the trends of the publication since the last 2 decades from now, and we see very rapid, the biggest number of the publication are published in the last 3 years. So that's after Donato et al., the one that I showed previously. So how do we do the data analysis? We use the carbon stock difference here, and the difference between the control and the treatment. So this is a carbon stock in the control, and this one is a carbon stock in the treatment. That's based on the IPCC guideline 2006, how to quantify the carbon emission coming from the land use recovery chains. And we come up with the annual carbon stock chains. That's applied for the vegetation biomass, including tree and root carbon stock. But for the soil carbon stock, it's not necessarily the same, because there is a process in terms of the carbon that compose those pools, I mean the soils. So that's why we use the response ratio effects. That's, we want to know the effect of the land use before and after effect of the control and after land use sites. We want to know how different or what is the change of the carbon stocks and also fluxes between those two types of the data. So here we have as a denominator, we have the mean of the control, and this one is the mean of the land use land cover change affected sites. And from this land response ratio, we can quantify the percentage of change between those two different control and treatment data. So here's the findings. So we have several land use category here. And the pink one is the overall land use average, and then this one is the carbon pool. This is trees, this is a belowground roots, this is a soil carbon, CO2 flux, and then methane. Some blanks are not available in terms of the data availability. And the means percentage change, meaning that there is a reduction of in terms of the carbon pools or fluxes following the land use land cover change, and the positive is the increase in terms of the number. So we find that as hypothesis in the land use transition, we clearly see that the carbon stock from the biomass are lost due to the land use land cover change. Like the mean is 80%. And the loss of the soil carbon is about 50%. And we didn't see clear pattern in terms of the flux change from the soils, and we predict that will be because the driver of the CO2 efflux are coming from the very complicated processes, biogeochemistry processes coming from the metabolism of the microorganism, oxidation and things, and that's why we didn't see the clear pattern of the flux change. So what is the implication of this percentage change if we bring back into our numbers previously? So basically the biomass will grow about 82% and the soil will grow about 50%. So if we have the mangrove globally about 9 million hectares in the world, so you just with the deforestation rates and then the land use land cover change rates is about something, you can multiply this with this number. So you can now have the refine the calculation of the global mangrove emission. So that's, but our study just finished until here because somebody else was doing this global scale calculation. Anyway, yeah. So this is the data that's showing to support our findings of the carbon loss in the carbon stock pools. Particularly this one is the soil carbon stock, and then the soil carbon content, and then bulk density. So here is the land response ratio, negative. This is a positive and negative. Negative meaning that the loss of the carbon soil is larger following the times in land use. So meaning that if you have the land use conversion since 30 years ago and compared to the last 5 years ago, the amount of the carbon loss is greater in the 13 years of land conversion from the mangroves. And that's also supported by the decrease of the soil carbon content and the increase of the soil bulk density, which is as in effect of the land collapse, because you remove the top biomass, the trees, you chop down the trees, and then the root will become decomposed, and then the land will become collapsed and then subsidized. So that's why the publicity is getting higher. And this one is the data of the forest structure data, basal area, tree density, and tree diameter showing the same patterns. And this is a regeneration effect. So we find that there are several types or definition in terms of the regenerating the mangrove. We have plantation, mangrove planting, we have mangrove rehabilitation, and we have mangrove restoration. And those having a different kind of terms, and that's why probably having the different effect also in terms of the sequestering the carbon. But in general, we saw that the carbon stocks in the biomass in the trees are back up to 150 ton carbon per hectare over the 40 years. Yeah, we predict by using the logistic regression. And the red one is the data that we gather from the low latitude with the high rainfall. For example, like Indonesia and Amazon, and yeah, like near the equator. But the blue one is the subtropical mangroves, where mangroves data collected from the Arabian and also the China, and they have a very lower in terms of the biomass sequestration. And the sequestration rates, it's about, by using our prediction, we predicted the rates of the sequestration is about 7 ton carbon per hectare, and it's still increasing for like up to the first 25 years, but decreasing afterwards. So what is the indication? So actually this study fit with the current policy ramification processes, such as IPCC wetland supplements. IPCC is Intergovernmental Panel on Climate Change. They have wetland supplements, which is contains the methodology how to quantify the carbon emission, carbon sequestration coming from the land use and cover change in the wetlands, including mangroves. So today, so the supplements launched in 2014, and there will be a revision in the next year. So our findings should be fit with the requirement with the IPCC and also IPCC reports. And importantly, there is a national determined contribution for carbon reduction target at the national scale, and it's part of the Paris Agreement in 2017. So they can use, I mean, like the countries that having the mangroves, having the high mangrove area with the high deforestation rate, with the high conversion rates, so they can use our data as a part of the tier 1 emission factor. And also, of course, we have a Ben who is experiencing working on the mangrove restoration program. And now is in the next 10 years, I guess the UN declare as a decade of the restoration. So our findings should be able to fit those programs. Like we know based on our findings that short-term restoration, like 5 years or less than 10 years, maybe it's not efficient, because we need longer time to to achieve the mangrove to achieve the carbon stock that already gone in the mangrove area. So it's need times. So yeah, the challenge is this is a collaborative work working with the teams from the 3 institutions. We have here Lindsay Clint from CDU, and also Sifo, Modiaso, and also in US, in Singapore, Mangrove Lab. So it's not easy, and we always arguing with the methods and scope and everything. It's not easy and long process, time consuming, and this study also provide diverse variables in terms of the unit. We have to convert the unit that provided by the paper into standardized one that we want. That's also time consuming too. And still limited data and language limitation as well. The mangroves are mostly present in the tropical countries, but they not necessarily published in the English, so that's why we have very limited data. And in our systematic review, we use the study that presented in English, Bahasa Indonesia, and French. And yeah, this is the way forward of the study. In the last 1 year, so the study published last year in Global Ecology and Conservation, showing the trend of the publication growth between the fieldwork-based studies, modeling, and data analysis. We can see that people or researchers now probably has limited care to the fieldwork data or publication compared to the analysis or review publication. So people eager to publish as a review or global analysis rather than a fieldwork-based data. And that's normal because sometimes if you publish like a systematic review or global review data, you can publish the high-impact journal, Nature, Science, and etc. But the fieldwork study maybe just apply for local scale, like here in the Northern Territory, like in Papua, and might be not applicable to be generated as a global conclusion. So that's why here in my PhD thesis, I also conducted a field data from the West Papua, particularly in the Bintuni Bay here, and several sites in Kaimana. And I conducted a systematic review, and we got the result, we got the trends, we got the variability of the data, and this is also similar with the field data that I gathered from the timber mangrove logging in West Papua. So the carbon stock increasing following the year after logging. Like they have already established 25 years long, and we also understand the local, like what is the process behind the carbon stock, particularly behind the carbon stock in the field studies, particularly in West Papua. So we find the patterns why the carbon stock there is so high compared to here in the Northern Territory, and then I map like using the remote sensing, combining with the remote sensing and field numbers. Also make a scale-up studies based on those data using the remote sensing available LULCC data that previously presented by Sonlevic. Yeah, we got the numbers too, and hopefully can be finished by this year. Thank you. Here.
Yeah. So, can you tell me a bit more about that?
So
Because that's quite unusual. It's out of that tropical zone.
yeah, right. So if I'm still remember correctly, so there are several issues in New Zealand where mangroves are invasive. So mangroves are growing everywhere there. I don't know exactly. Yeah, it's northern New Zealand, and they want to get rid of mangroves. Some of the policy makers or NGO, I don't know exactly, but there is some mangrove clearing happening because mangroves are invasive, they say. So that's why they mention the flux particularly, and the flux, the CO2 flux, comparing between the undisturbed and then the clearing mangroves.
Is that anything to do with global warming, that the mangroves are actually able to start growing there?
Yeah.
Change in the sea current, so they've got a warmer current going through there.
Yeah, I'm not quite
So that's
confident.
nature in action. That's
Yeah.
an invasive species.
I'm not quite confident in terms of this implication, but there are several papers that published in 2016 in PNAS and also Global Change Biology, showing that mangroves are going up in terms of the area or location. Some of the mangroves are going up in Florida here, and some also going down here in across the east coast of Australia.
So I met someone last year who was studying those mangroves, and she said that there are mangroves there naturally, but there are ones popping up in areas around Auckland Harbour, and there are quite wealthy houses down near the water, and they're blocking their views. So, and she, I think from memory, it was more to do with that sedimentation was kind of changing in the harbour, so mangroves were able to grow in areas where they weren't previously, and there was controversy around getting rid of them.
Yeah, like mosquitoes, we don't want them.
Yeah.
Veronica.
Yeah, right. Yeah.
Yeah.
Thank you. Yeah.
Sigit, just a few slides forward. I have a question. Next one. No? There. In the top right one,
This one.
yeah, is that what you said about the accumulation of carbon in Tonini Amagirong? What is that one where I'm pointing? Is that the,
Time since regeneration.
and how much carbon it has been collecting?
So how much carbon is in the here?
Yeah.
This is the trees, the above ground trees, and this one is the below ground root. But here is the rates, how much the accumulation is.
Yeah, so is there saturation? Is that why it's going down? So is there a maximum particles per million of carbon that can be stored in there? Is that why the saturation curve is going down?
Yeah. So yeah, this is the rates. Might be this is based on our data we compiled here. But this is the accumulated one. So the accumulated meaning that the stock there is once mangrove up to 40 years, they will not grow anymore.
Yeah.
Yeah. But they still sometimes produce the leaf litter, and that's the amount is becoming less because they probably don't grow like bigger,
Yeah,
but they still
plants,
produce as a litter
like
production. Yeah.
So that's a productivity rate.
Is that the last one is the productivity rate, and that it kind of
There's still
evens out at the end?
You can see the curve, they're still accumulating carbon.
Yeah, but it's very small.
It's probably half the rate at which they were accumulating in the first 20 years. So they still accumulate. So if you come back in 1,000 years, you'll have more than
So
that.
there's no saturation.
That's an unknown. It's an old
Probably
growth
at the
forest.
end of the day.
Okay.
So the paradigm, old growth forests don't sequester any more carbon, and then possibly net source, it's like an old growth rainforest, or an old growth wet temperate rainforest, or a temperate forest in the US or Europe. But recent evidence suggests they still slowly accumulate carbon. Even mountain ash forests in Australia still accumulate carbon, these guys still accumulate carbon, these guys are getting sticky with the soil.
Oh, wow. Okay. Thank you, Sigit.
Any other questions?
Yeah, I just have one question. So it was interesting that, only 37 studies out of all of them.
We get the 47?
37.
37, God, or worse. 47.
Had a control group and so was suitable for your systematic review. And of course, I guess once you whittled it down to the question, it doesn't have a control group or not. I think you were down to like 500 or so, and then you threw out a bunch then. And obviously there were, some of them probably were, just bad science, but some of them maybe were in locations where it wasn't possible to have control. So I just wondered if 376 papers excluded because no paired studies. So of those ones which didn't have poor data quality but just didn't have any paired studies, did you map where those were? I just wondered if, there was like some kind of spatial clumping to those, if they were sort of in some area which had been just so trashed that there were no controls, and obviously there'd be some which were just straight out.
So it was happening, this discussion in one of our workshop, in this 3 workshop, especially in the last one. So at the time, because we want to know the difference, the change. So unfortunately, very sad, we throw away in the study that have no pair, have most of the studies in the mangroves, carbon are collected from the undisturbed natural mangroves. Yeah, we have published a lot of from the undisturbed mangroves, but here we want to know exactly how those carbon are changed because of the land use and cover change. So that's why we threw away those studies, even though some studies that measure stock and fluxes in the shrimp pond area only, so we throw away.
Right.
But yeah, we did not collect as those 37. But of course, we have still the database around 400 something that mostly are N-pair study, like
Right.
just only natural or control or treatment only, basically.
Any
Yeah.
other questions for Sigit? Before we go and drink beer. All right, so if you still want to hit a mangrove action, do you want to have a word about next week?
You can.
Well, next week we've got part 2 of the mangrove land use change story, because Clint Cameron is going to give us a seminar next week. Clint will focus on a similar theme, but he'll focus a bit more on the actual emissions. He's going to compare emissions from mangrove disturbance to disturbance from other ecosystems around the world, only tropical. Is there anything else he's chucking in? I think it's mainly examining emissions as well.
Yeah, based on the field studies,
Yeah.
different sites that I have in West Papua, and then conducted the studies using the greenhouse gas emission directly in the field from the Sulawesi, in Indonesia still.
And he's also going to be presenting some of the further work he's going to be doing in Myanmar, Fiji, and
Oh yeah,
Good. Started in
Right.
India. So he's interested in setting up projects, carbon offset projects using mangrove degraded mangroves. Offsets are gained, how we're gaining carbon back by restoring, and given the richness in carbon density per hectare, that's quite feasible.
So-
Proposition.
Please note that Clint's seminar is going to be next Thursday from 3:30 to 4:30, and that's because on Friday we have 8 graduates from the college, and most of us are going to be celebrating with them. So next Thursday from 3:30 to 4:30 here, Clint will be giving his talk about his mangrove work in Indonesia, Myanmar, Fiji, and New Zealand. Thank you so much.
Thank you for coming.
Right,